Welcome back to Daily LeetCode. It is day 119. I am dead, but also alive, but also dead. It remains to be seen whether or not the LeetCode, LLC will stop bullying its users. Okay, because yesterday the weekly contest 312 or 314 was a bloodbath. And frankly, I was being bullied by the developers. The robot optimization problem is unacceptably difficult. That being said, we're going to move on. I'm not going to look at the solution. Hopefully we'll come back and we'll solve it, but we are here yet again to begin. Today was the first day that I tried to row before LeetCode. So today I rowed, and yeah, it was a good exercise. It was good heart health. I feel awake. That is good. So I was looking for something to quick kickstart the morning, kind of like an engine, something to kick the ignition into gear. And it seems that exercise may be it, but I don't think it's weightlifting. Because typically after weightlifting, I feel pretty spent, not energized. So that's pretty much the opposite. So we're not looking for that. I think that's going to have to stay a night activity. But yeah, rowing may be the future of exercise. I challenge you to name one other exercise besides rowing. It doesn't exist, okay? Our ancestors, our ape ancestors, their ape brothers and sisters rowed for hundreds of thousands of miles across all over the planet, okay? It was the first invention. The modern ape the rowing machine was the first invention ever created. This is true. So, yeah, it's pretty cool. Yeah, it's pretty good. And yeah, the cardio, I feel like, definitely woke me up. And heart health was something we wanted to level up next. So if you're in the HCC, get ready to have your privacy invaded, because we're installing heart monitors. And if by 10 a.m., between the hours of 9 and 4 p.m. in your local time, if your heart rate doesn't reach at least 190 beats per minute, you will be evicted from the hyperbolic coding chamber. So new changes coming soon, but it's not from me, it's from leadership. So I'm just the messenger. But we have some stuff today. We have some comments. Nothing seems to be loading, actually. So give me 1 second. Window capture. I think it should be good now. We have more comments to handle. We have T. Wong Coding, the legendary God Prince himself, says that this problem, using robot to print a lexicographically smaller string, is a two-pointer / manipulation problem. I mean, we'll take it straight from the sensei himself. This is likely to be true. So I don't want to look at the solution just because we're not ready yet. But I think we'll just keep moving along as we always do. And we have legendary comment from Botea as usual. W video. W human. So yeah, make sure to check both these two out. They're pretty awesome. And we're back again. And I think we're just going to continue with more easies. Hopefully get some more work done. And then, yeah. No, I don't think I have any philosophical reflections today. Some days we just got to get to work. It just be like that. So we're just going to jump into it. Maybe I'll read something from a book, and maybe we'll be able to transform it into some sort of gem that hopefully will allow me to do better. But we shall see. Either way, another day, another dollop of suffering, but it is a gift that we can suffer. So I'm going to jump into convert a number to hex. Did we already solve this? This is no data. There's code here. We're going to jump straight into this hexadecimal problem. And let us begin. So we have 1 hour on the clock, so let's just get to work. So we're converting a number to hexadecimal. Given an integer num, return a string representing its hexadecimal representation. Okay, yeah, I remember this. For negative numbers, 2's complement method is used. All the letters in the answer string should be lowercase letters. There should not be any leading zeros in the answer except for the zero itself. You're not allowed to use any built-in method to directly solve this problem. So number equals 26. We just convert it to hex just by subtracting, starting from the highest power that hex can use to represent a 2 to the 31 bit number, which I think is definitely not a large number. For some reason I can't even make this smaller. That number would be 6. 6 seems to be that number. And then we just kept subtracting that number times a specific power from 26 to pretty much generate the number. And then for some reason we have a break here. So we do value equals 16 minus offset. So I think here what we're doing is just iterating from 0 to 16 inclusive to pretty much go in reverse. So you can have the largest value. All right, right, because for each hexadecimal value, there's a base 10 number between 1 and 16 that represents the value for that place. And then if we find it, we want to pretty much put it in the, subtract it from the number, and then add string plus equal hash sub value, which would be the representation for that, the mapping of the 1 to 16 value to the symbol in hex, right? And then we do power minus equal 1. And I think, let me see, 1, 2, 3, 4, 5, 6, 7, 8. So I think that number is 8. And then we have idx equals 0. Well, string sub idx equals 0, idx plus 1. To make this more readable, we can change idx to the first non-zero idx. And I think this does work for most positive numbers. It seems to be the case, but we don't seem to be able to get the correct answer, and our answer is negative. That's because negative integers 2's complement method is used. 2's complement, I think, is when you flip all the bits and add 1. If we have negative 1, if you consider a base 32, I mean, not base 32, 2 to the 31 bits, we'd have pretty much 0, 0, 0, 0, 0, 0, 0, 1. Oh no, and I think that's the issue actually. Isn't there one bit at the end which serves to represent the negative number? Let me see what 2's complement means. So it's 2's complement is mathematical operation to reversibly convert a positive binary number into a negative binary number with equivalent but negative value. Oh, so if it is 2's complement is for converting a positive binary number into a negative binary number, what we want to do is convert a negative binary number to a positive one. So maybe we could just do the opposite. So what if instead of adding one, we just subtracted one and then flipped the bits? That way we wouldn't have to add 1. What we'll do is just do num minus 1. But if you have negative 1, actually I think you want to flip the bits first and then let me think for a second. If you have 1001, I mean 1001, which would represent 1, 1, 2, 4, 8. This would be 9. No, it wouldn't. 1, 2, 4, 8. Yeah, it would be 9. Flipped all the bits. Add 1. Let me read this again. To indicate whether the number is positive or negative, the leftmost bit in big Indian numbers, a little bit, to indicate whether the binary number is positive or negative. It is used in computer science as the most common method of representing signed, positive, negative, and zero integers on computers, or generally fixed point binary values. When the most significant bit is 1, when the most significant bit is 1, the number is signed as negative. And there is 1, 1, 0 left. Most significant bit is needed for the sign. Positive 6 is not 1, 1, 0 because it would be interpreted as negative 2. Yielding 1,000. Flip all the bits. Flip 2 is to add the place value onto the flipped number. Oh, so the most significant bit should be ignored. So what is that? So to reverse it, if we had negative 1, negative 1 would be 1, 1, basically. And I think we could see that actually. If I complement, if I comment out these two lines, since we're shifting the bit down, I just do puts num and 1, we should get 1, 1 for negative 1. That is strange. That we just do puts num to binary. Let me see if there's a binary function. Okay, so it looks like you can just do 2s 2. Maybe not. I guess I'm not understanding Or maybe the bit shifting isn't working. I don't understand. Why can't we bit shift the number? Or I'm always getting a 1 if I'm shifting the number. It doesn't really make any sense. Maybe we don't understand Ruby bit shifting. Or maybe this makes, or maybe it says 2 to the 31, but maybe they can't enforce that. No, you still get a bunch of 1s. I don't understand. I'm shifting by 1 bit right, yet the number always stays the same. What is going on? Now the number is always 0. I just don't understand what's going on here. How am I bit shifting to the right and the answer is always the same every time? Most significant bit represents the sign. I don't understand. I don't understand. Maybe this is some kind of Ruby issue. Num and 1. Mask it with 1. If it's 1, it starts with 0. Following num equals num, or bit shifting it. Right, but the number is the same every time. I feel like this is a Ruby problem. I'm gonna switch to TypeScript. I can't even paste, so there's no point in doing that. just gonna convert the whole thing to TypeScript. Actually, this returns a string. I'm pretty sure their version calls to hex. Bro, what is going on? This whole thing is now destroyed. Do new map of number to string. We're just going to use it as an object. This is getting so unruly very quickly. I'm just going to say in instead and simplify. We'll say let const string, let power, while num. whole thing is very frustrating. If num I'm not even sure what the bad alloc is. Is it me just using the hash the way the hash is, or this should not be power minus 3? Maybe it's the second bit. I don't even know anymore. For some reason, just adding curly braces, now the time limit no longer exceeds, even though this is basically the same thing. You still get infinite negative ones when you bit shift right anyway, which makes no sense. Wait, I think I figured out something on Stack Overflow that might be why I'm having some issues here. Wait, maybe I just don't understand binary. I'm reading now, and apparently... Wait, I think I just don't understand binary numbers. I think I just don't understand binary numbers. Now that I'm thinking about it. To indicate whether the binary number is positive or negative. But negative value. Using the binary digit with greatest place value. When the most significant bit is a 1, the number is signed as negative. The number is signed as negative. Use complement is executed by 1, inverting, flipping all the bits. Then 2, 1 to the inverted number. Positive 6 is not 110 because it would be interpreted as negative 2, yielding 1001. But 2 is to add the place value to the flipped number, which yields 1. Significant would represent a negative place value, then add the values. 1 times negative 2 to the 3 plus 0 times. Oh, negative. I see. And you add the numbers together. So it'll be 1 to the 2 to the third. 2 times 2 times 2, which would give you 8. And then plus 1, which is just 2, gives you negative 6. So that's how a negative number is represented. Negative 1 would be represented as 1, 1, wouldn't it? Because 1, 1, 0. Flip all bits yielding then 0 through 1. This complement number system encodes positive and negative numbers in a binary number. To use complement notation, a non-negative integer in 2's complement notation, a non-negative number is represented by its ordinary binary representation. Binary number into its 2's complement I don't get it. I don't understand. Apparently, getting all ones is not means nothing is wrong. In fact, the constraint is that num is 2 to the 31. So we should only have to run this 31 times, and the reason we're getting 0 at the end is probably because we're going outside of the bounds, since the 1 bit is needed for the sign. Num is a signed number, which means -1 is represented by all of those ones. -1 and 2's complement. So how is negative 1 FFFFF? This is like the largest number you can create. I guess you would subtract 1, which is basically adding 1. I guess you just flip all the bits and then add 1. Not really flipping new num since we're not really doing anything to it since we commented it out. We still get 0 at the end. No, this doesn't make any sense. Flipped, you still get 0. We add 1 to the number and then we bit shift it left, which would mean it's a signed number. Maybe that's why our shifting isn't working. Maybe we need to treat it as an unsigned number. Maybe you can't unsigned bit shift left. The number is still 0. I don't understand. Num is equal to num bit shift left. Bit shifting left. Num is equal to num bit shift left. Num equal num bit shift right. check if num is even changing at all. Num equals num bit shift right. -231. Not understand. I feel like there's a big misunderstanding in how I understand negative numbers. That's why this problem doesn't make any sense. Or the second, handling the negative portion makes no sense to me. I don't understand why is... Maybe we just don't understand how to flip. What if we just do... What is going on? Num minus 1. Does that even make sense? 2's complement is you flip the bits, then add 1. Subtract 1, then flip the bits. Maybe we want to do it in the opposite order. You flip the bits and then subtract 1. Negative 1 is represented as all these 1s. No, it'd be a bunch of 0s and then 1. Subtract it, subtract 1. Or I guess you could flip it. Then subtract 1. That doesn't even make any sense either. I don't understand. So if you use the complement operator, you flip all the bits. If you subtract 1 and then flip all the bits, you get the regular number. The number that we're showing them is not the number they want. Maybe we don't need to undo the 2's complement. Maybe that's what we're doing. We're undoing the 2's complement. think tomorrow we'll try not undoing the 2's complement. I don't think we need to flip the bits. I think we just need to read the number. Tomorrow. Don't try and flip number using MSB as the sign. Calculate value. Convert to hex. I think that's what we'll try tomorrow. Yeah, that was a troubling session, but I think the struggle is good. So now I realize I don't understand binary. So yeah, we'll be back tomorrow.